Okay, here's an ALEKS problem where we're going to use what we talked about, dimensional analysis, just making sure our units are in the right position as we set up math problems. And so we're given a problem. A gram of gasoline produces 45 kilojoules of energy when burned. Gasoline has a density of 0.77 grams per mil. So how would you calculate the amount of energy produced by burning 12 liters of gasoline? Okay, well again, I just set up all my problems essentially the same way. I write down everything I know, including conversion factors, and then I go from there. So let's write down what we know. We know that a gram of gasoline produces 45 kilojoules of energy when burned. Okay, so for every 1 gram of gasoline, then I produce 45.0 kilojoules of energy. Okay, so that's a conversion factor. I also know that gasoline has a density of 77 grams per mil. So I know that. And then I'm also given, I have 12 liters of gasoline that I'm going to burn. Okay, those are the three pieces of information that I have. You remember my strategies. I never ever ever start with a conversion factor. I just never do. I just start off with a lone type of value, and in this case 12 liters of gasoline. So that's my starting point. So I have 12 liters of gasoline. Okay, and I'm trying to get to how much energy is produced, and that energy is given by these kilojoules of energy. Okay, and so I know that I have liters. Well, I don't have any liters here my in my conversion factors, but I do have a volume in terms of milliliters. And I can certainly convert liters to milliliters, and so I know that in 1 liter of gas, there are 1,000 milliliters. All right, you should know that, or at least you should know how to look that up. All right, my liters cancel, and is this a true statement? In 1 liter, are there 1,000 milliliters? That part is true. Now I can use my conversion factor that in 1 milliliter of gasoline there are 0.77 grams of gasoline. Okay, my units again are going to cancel out my milliliters, and I'm left with grams of gasoline. And I can use my other conversion factor now just by flipping it around and say that for every 1 gram of gasoline, then I create 45.0 kilojoules when burned. My grams of gasoline will cancel out. Is this a true statement? Well, it is, because the problem gave me that. And so if I was to actually do that math, now ALEKS doesn't want you to do it. They just say put in the equation. But this is exactly how I would put in that equation. Okay, remember these are going to be multiplications in between here. Okay, so that is how I would do this particular problem. That's how I would set it up. So again, my strategy is write down everything I know, including conversion factors. Don't start with a conversion factor. Rarely, if ever, do I do that. And then start with the value that's given me and just work the problem based upon looking at my units. I really didn't care about the numbers, but I do care about my units. And in fact, when I'm in the lab actually doing this, it's units that guide almost all of my calculations, even some very, very intense and hard calculations. Then I need to make sure that my units can guide me. So you can do these problems, just think them through and use that strategy that I taught you.